I will mention probably more down-to-earth things about myself. Basically, I always think of myself as a mathematics teacher, and that's been the dominant thing in my life, really, which I still love, and silly enough to go back and do it still when someone twists my arm just a little bit. For some reason, my wife gives way because she says, okay, you enjoy it, you can go, but I still love maths teaching, the main thing. I can say my life has been totally dominated by this for the last 2.5 years. And I know you're going through a lot more than I am, but I can say I appreciate how much is being asked of you. There's no question of that, and what's going on. And today, the main thing I can do, you'll see my slides in a second up, assessment, it's called assessment. And I'm talking about assessment, but mainly what we can do to help, basically. That's all it is. I wouldn't be presumptuous enough to actually come up and give you that guidance. That's the QCAA, and for you to talk amongst yourselves too. And when I say that, I certainly welcome any conversations today. Don't worry about interrupting at all. I welcome comments, and this is another valuable opportunity just to hear what other people are doing. So I think that's been one of the features of our sessions up here, that people have really appreciated being able to talk to other maths teachers. I think many of the people here come from a tighter set of schools possibly than the other two other sessions we've been at, but still, that's a valuable opportunity to have. Okay, so we'll start off. We'll go through year 10 and before. Some of these things, let me say, I'm sure you will think they are obvious and you are doing them, and that's good. And as I say, it's a little presumptuous of me to put it through, but what I'll try and do is slot in what CUP are trying to do. And when I say that, I'm going to actually take the opportunity to say something about Cambridge University Press too. Cambridge University Press is not like the other publishing companies in the sense that it's fully owned by the University of Cambridge. There's no shareholders, profits don't go off to someone else. In actual fact, the charter says that they're there to foster education. And it's a nice sense when you're working with them that that's an aim of the actual organisation. It's not a company, it's a fully owned part of Cambridge University. Okay, so let's go through. Start having assessments that reflect the Year 12 assessments. So you do the technology free and tests, you do the technology active. If possible, you get them to use the type of calculator they're going to use later on. You've got that situation where you have, they're going to go through to general or essential, they're going to be using scientific. If they're in methods or specialists, they're using graphics. From conversations, I think many schools are separating people off in year 10 to some degree, and it gives them an extra year to get used to that calculator. With the external exams, just the pressure that the students are under, it's going to be another set of pressures. Familiarity with those calculators is of paramount importance. They can't be learning about their calculators. For the first couple of years down in Victoria, I'm going to say Victoria a few times, and I won't excuse myself for doing so because that's where my experience is, but for the first few years when we introduced graphics calculators down there, we were having trouble with things like calculators freezing in exams. And then the student actually has to apply for special consideration. Gradually, that was taken away. It was just said, that's your business, you have to know how your calculator works. If you send it into a loop, you have to know how to get out of it. Now, the QCAA might be very kind to start with, but probably after a while they'll think about things like that too. So the student should be always aware of what happens when their calculator does something unpleasant. I think you know with graphics calculators, they can still freeze if you put something nasty in there. Make sure they know what to do. That alone, and they want to use things efficiently. They want to use the right parts of the calculators to get answers. And that's something that's worth teaching, especially if you can do it at year 10 and year 11. I think in year 12, you'd rather not be talking about calculators. Most of the time, you're talking about the maths. There's not enough time in that year. Okay, degree of difficulty. I think we can say with degree of difficulty, we've always been conscious of levels of demand of questions, of cognitive demand. And so what this is a new set of names. And obviously they're important names, and the QCAA, I don't want to understate the importance in terms of that, but the point is really, is that it's something we've always known about. This is a new set of names to work with. And it's a good way to think about it in all year levels. You don't want to just keep on doing simple familiar things all the time with students. You want to actually push beyond that. And good maths teaching has always said that. Look at how your Year 10 courses flow into the Year 11 course. My feeling is, and we hear, and I'm certainly not going to contradict it, Math Methods 1 and 2 is very big. Math Methods 3 and 4 is very big. You want to make sure that students are coming in with as much knowledge as you possibly can without just teaching the course. But things like the algebra demands, if people have everything about linear equations and quadratic functions, linear and quadratic functions, then it's a very good start, isn't it? It makes those first few weeks much easier. And in actual fact, a lot of the work just flows from there. Also, one of the things we found down there with exams with technology free, with probability, the probability was okay. Where did the problem come? Fractions. All of a sudden, students have to know fractions pretty well. To do technology free, they have to know how to do fractions. And it's something to make sure of, and it probably gives some more motivation lower down the school for going into those things. The last point seems to contradict everything I've said, but I think in actual fact it's very important, because good mathematics teaching is not just about teaching for that final exam all the way through. That's just, I don't think that's on. All the way through, you want to give students opportunities to develop in different ways their mathematical thinking. And it's not all going to be, you'll need this for the exam. That doesn't have to be the total motivation. I can say I was head of departments for probably 30, 40 years, between 30 and 40 years, and I made sure that those departments weren't just focused towards final external exams, worth repeating, final external exams. It wasn't worth doing that, it wasn't good for them, it wasn't good for the teaching staff to think that way. Abigail is going to talk more about this, and I'm going to keep it very brief today. And I'm talking about what's available. There are problem-solving modelling type questions in the book. I know they're not QCAA independent, right? They don't even pretend to be. We've got 2 levels of them, but what they are some ideas that you may grab hold of and use in other ways. The students can actually benefit from doing them too, of course, just as they are, but at Year 11, when they're getting used to things, it was no good me putting in a whole list of independent problem-solving modelling tasks. That's not what they need to start with. They need to have some guidance as well. And that was the idea of doing that. The ones that are online, downloadable, start with a guided problem solving, but then suggest how they can be turned into independent. Again, they're there just to give you more ideas. Okay, what's there for exams? They're downloadable. Unit 1 exams are up there now for general, methods and specialist. And people at the other sessions have said they've been using those questions quite a lot. Either some people have been using the exam actually for their Unit 1 exam, which is fine, but quite a lot of other people have just been taking questions off them and making use of them that way, or using them for revision for their classes, for the exams. So we'll keep doing that. Unit 2 exams are up soon. In methods, there's 5 revision chapters. There's enough questions in those books. That's one thing I do know. There are enough questions to actually stretch students in lots of different directions. Online downloadable assignments, and there are 3 online downloadable tests for each chapter. So that's true, especially in methods and specialist. My favourite book actually is Specialist 1 and 2. It's just some of the chapters, they're quite new. Things like the number and proof chapter have been developed in the last 3-4 years. We've worked at them very hard, and they're nice topics. Proof and number and combinatorics, great. They don't lead straight into Year 12 topics, but they're still great to do. For people teaching the specialist course, you'll notice in proof and number we put in induction. We know that's not in the Year 11 course, but it gives people the opportunity to do that there as well if they want to. It's obviously within the syllabus in a rough sense because it's proof. And so it satisfies those things. So it's possible to actually do 2 doses of induction if you want to do so. Okay. I'll mention the online chapters because people don't see them and they're a little bit hard to find. You'll see them in the table of contents. They are in the PDF version of the book. So you'll find that there's motion in a straight line, which goes beyond the little bits which are in methods. So if you want to actually give students more before they got into specialist maths or for some more of this sort of material for math methods in year 12, there's a whole chapter on it there which goes into things like velocity time graphs, which it's not in the syllabus but in year 11, but in actual fact it's useful to have that understanding before they go into some of the concepts in year 12. The other one, this chapter can be very valuable. I've taught from it in year 11, and it's designed for the inference chapters in both methods and specialists. So this is a year 11 version. It's not in year 11 in Victoria either, by the way. All the inference takes place in year 12, same in every state. In every state, the inferences is taking place in year 12. We thought that's a bit much if students haven't thought about these ideas before. So what we've done is done a slightly more numeric approach in year 11. So the main idea is that when you take a sample, you don't get the same result every time. There's a distribution of proportions. If you can get this idea across to students, that, believe it or not, I think that's the hardest concept. That you don't get the same thing every time, you get a distribution. And the following slide, you'll see the picture. What's happened there, you've got an experiment where the probability is actually, there's 0.54, 54 out of 100, something in blue. And then you start taking samples out of this. And what happens? You don't get 54 every time, right? It spreads as much as that. This actually comes as somewhat of a surprise to students. Partly because down lower in the school, they've often been taught about, counting yellow cars that go past something or other and working out a probability. Well, life's not like that. You don't get the same thing every time. And so this idea of having a distribution can be introduced in year 11. And when they get through to sampling and in year 12, in both specialists and methods, they've got a pretty good idea of what the topic's about and what it's looking at. It's looking at how these results are distributed. These things are proportions. So you've got all those experiments. Each dot represents a sample. So each time you take it, you're getting something different. Sometimes you're only getting 0.4. Sometimes you're getting, 0.68 probably? 0.68. It goes to those extremes. So 0.68 of your sample was produced. So as I say, this is a somewhat surprise to students. And on the right, you can see in actual fact the idea that normal comes into it as well. They can see that in year 11 that you get bell-shaped curves quite often always actually from sampling distributions with sufficient samples. You'll always get this shape. And the same thing in specialists. People wonder why you've done proportions in methods and then you do means in specialists. But simply, the proportions work quite nicely from the binomial and then the normal approximation of binomial. So it fits nicely in methods. Actually, mathematically, it's sort of intact. Whereas when you do means in specialists, it depends on the central limit theorem. This is different, isn't it? I think I can say that's different. The books are tightly arranged into Unit 3 and Unit 4. So they start off with Unit 3, and you'll find first of all, there's a set of chapters which are more or less, they're review chapters of Year 11 work, but they're not just a repeat of the Year 11 books. So there's things like trigonometry in there, which is not actually on the Year 12 syllabus, but students will still have to know about trigonometry. Everything in Math Methods 1 and 2 has to be known for both Math Methods 3-4 and Specialist 3-4. But they'll have it in the one book, so they can look back and see these things. All about functions is in one of these early chapters. Then we actually start going into the actual units, and you'll find that the first chapter becomes Unit 3, Topic 1, and the next chapter is Unit 3, Topic 2. It actually does divide up like that. So I was talking to people before, when we started writing, we didn't have as much information. As time went on, we had more information, and so we could actually shape it more into the style. So when I think you look at these Year 12 books, you'll find they're more tightly aligned than the Year 11 books even. Year 11 books do the syllabus, there's no question about that, but these are just more obviously Queensland. They're totally rewritten. I can say, I'm doing solutions now, and I had to do a lot of new solutions. huge amounts, because once you rearrange like that, you've got the questions in the wrong places, basically, so a lot has to be added. So these books are even more tilted to what's happened up here, and we've got a bit more experience. We've seen more Unit 3 and Unit 4 sample exams, etc. So as time went on, I started to learn a bit more too. Some of the preliminary topics, we can just flick through these, right? They're preliminaries. So they've got all those things in there, refresh on differentiation. They've done it in Year 11. Strictly, it's not a Year 12 topic, it's a Year 11 topic. It just runs through the things again. They can go back and do the Year 11 book if they want to. Kim will point out, if you use the Year 12 book, then the students will be given access to all the Year 11 material anyway. They'll be part of it. But it's nice having it in the book where the student can just look back and focus in on that, these two as well. Probability, obviously in Year 12, there's no listing of basic probability ideas. But will they have to know conditional probability in Year 12? Yes, of course. So they'll actually have to practice those skills in Year 11, but they can revise in Year 12 with this chapter. All the questions are new. They're not questions from the Year 11 book. So they're brand new questions, so the students can do it during holidays, or you can set them off on weekends, or whatever you like. You'll find that students will be doing these things for sure. It's crowded already, but just keep in mind they have to remember all this Year 11 stuff. I'll stop there just to see if there's any questions up to there or comments. Does anyone want to actually talk about some of the experiences they're having with their math methods courses? I can say, by the way, this course, Math Methods, for instance, is in every state in some form or other. And it's more or less the same size, more or less. It might be a topic more here, but more or less the same size. But the comment's the same everywhere. It's a big course. And your comment is one that's often made too. If they knew all their arithmetic and their algebra when they got into Year 11, that would be okay. But we know this doesn't happen. This doesn't happen. I mean, I've taught for a lot of time, and certainly even though I had 10 years at the university, I went back into teaching again sort of in the last 5 years too, so I know what's happening now too. So students don't know these things, but all we can do is maybe it gives us a little bit more ammunition when you're talking to them to say, this is going to be important, to get it right now will save you a lot of pain. Doesn't always work, does it? But you can try. Yes. They will spend a lot of time on it. Why? Because it's worth that much of the course. Yeah. I can say that I've been visiting schools a lot since I've been here. Some schools are even doing it this year, yes, in last term, because they're so scared of the students being obsessed with the problem-solving modelling tasks next year that would block them out of being able to get through those big courses. Mm. You have to have students who are at the right level to do it, though, at that stage too. So it's not going to be right for everyone, but I think it is a concern. Somehow you have to control it and make sure that it's not just absorbing them fully over that time. Because if the course is big, it's going to seem a lot bigger if they disappear for a month, basically. So you need to think like that, I think. I can say we have been through that in Victoria in the 90s, and it was very tough. It really dragged the students off, and you actually had to drag them back into the course. Over time, what's happened in Victoria is everything's scaled against the exam. And what happens then is gradually these things become unimportant. So it's not there now. That's what happens. Everything gets scaled again. The school puts in their results, then it gets scaled against the exam, out it comes. And all it is the ranking the schools give. So Victoria's different, but yours is the mark goes in. Yeah, it's not an easy course, and I think we're hearing around schools that you've got this shift of people moving from methods to general, etc. And this is widespread. Don't worry if you think it's only you where it's happening, because everywhere I've been, I was at Brisbane Boys College, for instance. That's happening, right? Somerville House was worried about it. It wasn't happening yet because their results weren't in, but they were worried about it, losing numbers from specialists, for instance. I think already we've sort of got indications that specialist numbers are slightly less than they were. Please support your specialist students. Please keep them doing it. It's hard, but the reward will be there. It's one of the things, the points I've been making is, there's not only you under the hammer, the QCAA is under the hammer too, right? You have to remember that. They can't have it being a big flop. They can't have lots of people failing or the results, students getting distressed. You have to work on that basis too. That you're not alone. You've got the QCAA who are under the hammer as well, and the government, right? They're responsible for putting this in. So when you're thinking about these things, it's best to, for you and the students to understand that the bigger picture sometimes. 50% won't be a pass mark probably, for instance. Forget the 50% always. It won't happen. I can tell people, and this is a secret, people who get C in Victoria for methods know nothing. If they just get C, they know nothing just about. I'm exaggerating, but you know, you wouldn't like to trust them to do any maths later on, basically. All right, so what I'm saying is, they don't all have to totally master the course completely to survive. Of course, that's our aim, but just be careful with the way you're thinking. I think that is true, that you're not used to that system, and it will, I'm sure it's going to happen. If the exams are a decent standard, you'll find that there's a stretch. So the good students will be able to do everything, there's no doubt about that, but there'll be a lot of students who can only do bits, right? And I suspect a lot of them will be able to do SFs mainly, simple familiars, and do little bits of the others. It's going to happen because that's the nature of populations. So I'm only saying this to make people feel more comfortable in their immediate environment, basically. You keep on doing your best, you keep on pushing. Some of the students are going to go, they'll demolish everything, won't they? There are students like that. I know up here there's lots of good students. So some will demolish everything. They'll enjoy it, every last drop of it, and be able to do everything, but there'll be others who just struggle with it. And it's important to let those people keep going. They'll get something out of the course, but it won't be mastery. Okay, let's keep going. Problem-solving modelling tasks. We're gradually putting these things up. You'll find in the, on the site, there's also always an indication that something's been renewed, and things are going up regularly. So this is an example. There's lots of, there's the QCAA ones. This idea comes into the logo, or doing shapes, basically. How do you do these? One of the best ideas for doing these things is to have smooth joins. So you've seen this family of problems. You can do, you know, mapping bicycle paths or particular shapes, and you want the joins to be smooth. So as soon as you've done that, you've got a little bit of complexity in it because you need the derivatives to be equal. They have to be derivable piecewise defined functions. So there's a whole family of problems like that. The other ones are data-driven. The trouble with the data-driven ones is you have to get the data set. And someone asked me yesterday, where do you get those? Well, there's no nice website that says data sets for PSMT's Queensland. There's no such data site, no such site. And so we can do our best. I mean, I've seen some very nice ones. We've got one up for Unit 1, for instance, which I think is on ultraviolet at different stages of the day, and modelling that in different ways. So doing the shapes, this is a shape, one cross-section of a swimming pool, is one idea. You can do, this is very simple, mainly because I just want to do a simple diagram to start with. But you can see there, I've taken the trouble to make sure it's a graphing package that's done it. You can see the nice curve, nice smooth curve in it. You can also look at rates, because how do you measure the depths of pools? Usually by height, not by volume. So you get the relationship between the depth at a particular point and the volume, because it's going to be a piecewise defined function, isn't it? So there's complexity in it. They can be a water feature. They can be a fountain. All of these things are possible in that family. So for people who I'm sure you've all thought about, I'm certainly not going to ask you to divulge that because you'll all be keeping it. But we're putting these up. This should be up in the next month too. So gradually it's getting there. I put this up. You think, why is that there? That's the 500th anniversary of his death, which is worth knowing actually, because he's one of the miraculous people of our history. But the next one explains why. There's a general maths task. Vitruvian man, and looking at the different proportions. You can actually do real data sets on this basically, which there's lots of, like by people taking measurements. you can actually look and see if people actually, if your data actually supports some of these ideas. So I think in general maths, the data one, there's lots of possibilities. This one's going to be student generated, but you've seen others on the site too. These are slightly easier to get. But doing these things, there's plenty to ask in there and to test it out. So you can do things like this. In general maths, I was talking to Abigail about this before. It looks very scary, doesn't it, General Maths 3-4? I think one of the reasons people are finding that it looks scary is that it's material you haven't taught before. This particular course is being taught, and bits of it are being taught in every state, and it's not that hard. Abigail brought up the problem that it's so straightforward in some ways it's going to be hard to get complex unfamiliars.
The problem we have, I think, is that we have in the syllabus that it's going to be complex unfamiliar. And so, I don't think we can just teach the questions, because the very nature of the way they've defined the syllabus. And I think that, I was just saying, I think that's what's scary for us, is that you don't have any way to go, oh, if I was teaching, A-level maths, I would just say, learn these 4 things to do, because that's what the only thing that's been asked in the last 10 years. If you look at Victoria's, only one networks problem has been asked in this. It's always the same question. But we don't know that. And we also know that they've defined it as complex unfamiliar, so we don't know how they are planning to integrate it with other stuff.
But I think you'll find that there'll be a fair dose of those standard questions there
too
in any exam.
Yeah, and
that's the comforting bit,
yeah,
isn't
and
it?
hopefully those will be the complex familiar questions as well, yeah.
The comforting thing is some of these things like time series, you teach the techniques and they just vary the numbers a bit and you do the same thing.
Yeah, and that's certainly what happens if you have a really fun time, which I did, going online and looking at all the past papers. So a super fun weekend.
So I think it's important for people to understand that the course isn't that hard, really, the actual material. And if you look at A levels, you look at the other states, it's not too bad. There'll be this problem with the complexity, but the material itself is teachable to a wide range. There's 30,000 students in Victoria doing that course, right? 30,000. 10,000 of them don't know too much about it, but there are 20,000 who do. No, you have to be realistic about this, but that's, yeah. Never go down there and say, you said that, by the way. That's, okay, let's keep going. Look, there's things all the way through the book. You know, there's things like designing a tent. This is a favourite one. I think it's actually listed in the QCAA. I noticed it later on that there was a designing a tent. That's endless, right? Because you can just do tents of constant cross-section, but you can use different flaps and all those sorts of things to work with it and get areas, etc. So there's lots of possibilities. This is in the Math Methods 1-2 book. So you could actually vary these things. I've used a cap, but they need to be given formulas to work that out. So in the book, the formulas are given. Okay, there's a favourite, drug doses. That's in our Unit 2 problem-solving modelling task for Math Methods up online. And it's a really nice question because you get this piecewise defined function of the redosing. And it's got all those terrible transformations in it as you move through, because you need to do the different times, but just doing the functions. The one on the left's just exponential, so it's just exponential decline of the drug, and you're building up, it gradually builds up. Exponential is not an accurate measure of drug absorption, really, but it gives them something to talk about, doesn't it? What's wrong with this? Well, this doesn't happen. Given this model, it would just keep on getting more and more and more until, obviously, there's some hiccup. The next one is more realistic, and I've got 0.4t times 0.9 to the t. In year 12, you'd make sure it was e to the power. Because you can always write it in terms of e, and therefore you can differentiate it, find the turning points, etc., find the slope at different points, find the rate of decrease, the rate of increase. Lots and lots of questions. There's an online chapter in Specialist Maths 3-4, which we've titled Modelling with Matrices. Many of the matrix topics are dependent on eigenvalues and eigenvectors in reality. So Leslie matrices and Leontief matrices and Markov. Why do you get the steady state and why do you get different rates? The rates are measured by eigenvalues, right? And the eigenvectors are steady state. So it's not examinable. There's a section there that says, I think Leslie and dominance are examinable and the rest isn't. But they won't ask about eigenvalues and eigenvectors in the exam either. But the bottom line is that's why it all works. So if someone was doing a PSMT on using Leslie's or Leontief, then it'd be nice for them to understand how it's put together. I've used, it's a chapter of about 30 pages that takes you through those ideas. And a lot of the ideas were based on a book called Anton, Applications of Linear Algebra. And you'll find that in university libraries. And I'm sure whoever wrote the syllabus had a copy of Anton, Applications of Linear Algebra in front of them because it covers every last drop of it. It's about this thick though. You know, it's one of those American college books or university books. So it's sort of 800 pages. This is 30 pages, but it takes you through that material if you want to go that way. You have a choice in specialist maths because it could be vector calculus too, couldn't it, or complex numbers or matrices. So you've got a choice. I'm actually going to be putting up a PSMT in the next month too about a sideshow with a wheel with rotating carriages on it, because vector calculus can actually describe these things beautifully. It's just a vector sum of motion. There's lots of things with vector calculus you can do. As soon as things move, vector calculus describes it very nicely in space and very powerfully. It's one of the great things you can do in school maths. Here's the contents. Dominant eigenvalues is really the linchpin here. To use dominant eigenvalues in working with Leslie matrices, it works with Leontief too. It's a nice concept. You can actually see this rate coming out. All of the calculators can actually calculate eigenvalues and eigenvectors. With Casio, you need to have a program, so you have to download a package. With the TI, it's built in. TI Inspire in particular is very friendly, so it will spill out the eigenvalues and eigenvectors. So they don't have to spend hours doing calculations. You wouldn't want that to happen. So all of these things, again, it's an online chapter which is there to support problem-solving modelling tasks. Okay, so preparing for the exam. This is IA2. There's lots of tests online. The actual, when I say online, downloadable online. The actual electronic tests are only on chapters, but there's a lot more questions up there. So sometimes 3 and often 4 tests. One of those tests is broken up into the 3 degree of difficulty categories. So you get the 3 different types of questions allocated like that. In revision of Unit 3, in each book there is a revision chapter for Unit 3. The Year 12 books, you know when you're in Unit 3, I can tell you well and truly. You're in Unit 3, here's the revision. Right, so you can go through that and it's got multiple choice. We hear, it doesn't seem to be written anywhere, but the QCA are saying it. I've been in the QCA this week again, so they're still saying multiple choice going to be there. What we don't know is what the proportion is. So, and no one, well, sorry, someone does know it, but not me. And so you've got all these things, multiple choice, technology free, degree of difficulty arranged. So they're getting ready for that exam. Okay, you're writing them now, and some of you are actually starting to load it up with some trepidation. But this will help you support it. We're just this month we'll get up the Unit 3 practice exams. I can say I've got drafts of the 3, and it's just a matter of making sure that we've got them right. So they'll be up this month. So it just gives you more to use for practice. Or if you haven't written it already, you might like to adapt questions. When we wrote them, I can say one of the overriding factors was we looked at the QCIA sample and we've mirrored that. At the moment, that's the safest thing to do. You can't copy the questions because that's pointless, because you're not allowed to do it either and I'm not. But you can do like questions. So we've gone through doing that and we follow the marking scheme. I hear the marking scheme's changing, but we use the half marks. I think the strong rumour is we're going to full marks. Have other people heard that? No. It seems to be the half mark system is going to disappear and we're going to full marks. And they'll change things a little bit. As soon as we see that, when the mocks come up next month, then we'll change our marking schemes too. Just to prove we've got a bit there. We're making sure you can recognise that just about, can't you? Because all you do is think, there's the QCAA one, but it's the QCAA one with different functions. You're allowed to do that too, because it's natural, right? You can actually say, okay, I'm going to have a question which part does that, and then part does that. I think in the end, strangely, they classified this as complex familiar. And I noticed my editor actually separated it off into a separate question because she felt unhappy having simple familiar and complex familiar in the one question. But you'll find this sort of range of questions in there, and in the next one you'll see, you've got the idea. It's the same sorts of questions again. You're finding areas. This is technology active, so determine the coordinates of points A and B, and the functions are ones where you can't solve it analytically. You have to use your calculator. So again, it's the same idea. At the moment, the QCAA seem quite fond of people using their calculator to get approximations. So we'll follow that too. We'll have questions like that where you use your calculator to find the approximation, then find the approximate area. So these are, I've seen a draft where it's all beautifully set out, just like the QCAA. It's on my computer today, where these questions have been taken the step extra. So you'll have those maybe before the holidays, but at least during the holidays at the worst case scenario. I don't have to read that, do I? It says the same thing goes on for Unit 4. There is so much there to do. There are so many questions that there won't be any trouble in actual finding enough revision material. That's sort of endless. And the same thing we'll be doing the practice exams for IO3. We'll be going a step further because we'll see a little bit more from the QCAA and be able to go from there too. The final preparation, complete revision in text, there's actually a Unit 3 and 4 revision as well as the Unit 3 revision, the Unit 4 revision. There's a final revision chapter which has got hundreds of questions in it, literally. And they can use those too. Complete practice exams, including the QCAA. We'll have 2 on our site, so for each subject we'll put up 2 practice exams too. Again, once we see the mocks, we'll feel more confident in producing those. We'd be silly to do it until we see that. So the intention is to do that though. Practice exams are very important, and you've got all that time, haven't you, in Term 4, in theory. I don't know how people got strategies for how to handle that Unit 4 exam and then going on to the final exam, because there's quite a big gap, isn't there? Does anyone want to share what their thoughts on that one are? I've heard a few people talk about it. I'll give you a shared thought. Some people think they'll only sort of 3/4 teach a topic, but they can still put the question on the Unit 4 exam, because everything's meant to be represented in some way or other at different levels of complexity. But then they'll reserve some of the teaching until after that exam, because you've got quite a lot of time, haven't you? They don't really, you wouldn't expect them to finish at the end of the unit when the Unit 4 exam is. It's too early. So the thing to think is how you can actually manage that. How can you legitimately, following the QCAA regulations, how can you prepare the students for the Unit 4 exam, but then you don't want to just do well, it'd be nice just to do revision for 7 or 8 weeks, but 7 weeks. It'd be nice to do that, but maybe that's not necessary. Maybe you can take the pressure off and do a little bit after. Students need to become aware of what is required in Year 11, 12 and earlier years. So what we're talking about is if they really know all those prerequisites, you're set, aren't they? In fact, I'd nearly say the courses are easy. If they really knew all those prerequisites, easy. So that's the thing to aim for. It leads directly to Math Methods 3-4, and I may add also to Specialist Maths 3-4, right, which is scary. So the stuff they learn in Math Methods 1 and 2 has to be known in both subjects. And the students have to understand that that makes the Year 11 course different, doesn't it, from everything else they do, where, you know, if you're doing history, you do a history of a particular period and you learn techniques, obviously. But here, and you don't use that again, but here you go through and you actually use that idea distinctly again, explicitly, right? Explicitly use it again. So it's different from the other subjects they do. Topics in Specialists 1 and 2, such as proof and number and circle geometry, help more mature students to make more mature students in mathematics. I love those topics, so, you know, and combinatorics, they're great. And they really do add to a student's experience. Must be very familiar with their calculator. They have to be able to use it with fluency. Revision should be continual. Okay, doing exams. I can say this list is used actually by examiners in Victoria for the sum up, basically. What should students do for exams? This is some of the things. Make use of the perusal time. You don't just look out, if you were in this room, you'd be just staring out the window probably, but this is not a good structure, right? You have to use that time really efficiently. Take time when drawing graphs, scale axes, check of coordinates required. You can lose marks depending on marking schemes. If someone says, give the coordinates of the intercept with the axes and you write down 3, strictly if the mark is nasty, they could write, that's wrong, you need to write bracket 3, comma 0, bracket. These things, it depends on how the questions are asked and depends on the marking rules. Transcribe results from calculator correctly. You know how you do that, where you do the digit swap? Just like I did before with one of the words. You do the digit swap and it can't be marked correct. That's one of the things. You can't think, oh look, he nearly got it or she nearly got it. Right? We'll just get the mark. The marking scheme in the external exam, if it's not exactly the answer, off it goes. That has to be the rule because otherwise people don't know. Otherwise it's reading into the situation. Put units in the final answer and check that the final answer makes sense. What's the easy example? Probability is greater than 1. You'll be amazed at how many students write probability is greater than 1. They do all the calculation, they write down the answers, 32 over, not 29. And we know how it's easy to get that, but the student should be thinking, that was wrong. They don't though. So it's really just going back to make sure that it makes sense mathematically even. Right, I think in actual fact that was a good rush, but I think it was necessary.
I teach maths at Brisbane Grammar School and I feel very much like I'm about to start teaching 12 Maths A period 6 on a Friday. I'm really sorry to delay you, I'll be really fast. I did, you can tell from my accent, I learnt maths and went to school in the UK. I taught in big comprehensive, so big state schools in the UK, and then I came to Australia and I could only get a job in the independent sector because the state sector said they'd send me out west and I had little kids. So I had to suddenly change from teaching in big state schools to teaching at a big boys independent school. So I then threw myself pretty wholeheartedly into trying to learn how the Queensland system worked, and I've done that again. Like as we've come into this new system, I've done quite a lot of stuff with the QCAA. So basically, if they've advertised for anything, I've gone, oh, yes, me, really early on, which is a bit tragic, but I just really wanted to understand the new system because I came from an external exam system in the UK, and I learnt maths through Cambridge University Press textbooks when I was a kid. There's one that I think you had here called the SMP books, which how I learnt, and then I used to teach with the SMP books as well. So that's who I am. Hello. I got really interested in the problem solving and modelling tasks because I was interested in the endorsement trial, okay, hands up, totally honestly, I don't like the PSMTs, all right? Because they're pushed by a couple of people who I like a great deal, both the individuals, I like them a great deal, but they're always talking about how it's really important that children learn to model mathematics. And I'm like, yeah, but that's a science lesson. But they're a reality, so I have to actually learn how to do them and do a good job of them, yeah? So we have started doing PSMTs in Year 9. And so we do a PSMT in Semester 1 of Year 9, and one in Semester 2 of Year 9, and one in Semester 1 of Year 10, and one in Semester 2 of Year 10, and we've just done one in Semester 1 of Year 11, okay? We all hate marking them, like comprehensively loathe it, all right? We have calibration meetings, we all get together and talk about it. And sorry, one more thing which shows what a tragic case I am. Last year I did a course with the ACER, which you might have seen advertised, which is about assessment for learning. So it's like thinking about the theory of assessment. And having done that course, I can see that a lot of people at the QCAA did that course because a lot of what they're telling you about like the theory of assessment comes through. It's stuff I learnt with the ACER. And what that left me with is that when it comes to the PSMT, and this is going to sound really awful of me, but I think we need to teach the kids how the ISMG works as much as we need to teach them the maths, yeah? So what we do early on in year 9 is start to go, hey, this is the ISMG. How did what you did satisfy the requirements? What I've got out of all the sort of stuff I've done with the QCAA and with ACER is we just have to show the kids how the ISMG works, yeah? And what we're thinking is that we'll try and like develop that through the years. Now, whether that means that we kind of start by just getting kids to formulate and solve, or whether it means that we'll formulate it and then they'll solve and evaluate like how we do it, we kind of probably haven't got that sorted out entirely in our own heads. What we've done is to give the ISMG to the year 8s, but then we've written, like in the marking guide that we hand out to them at the beginning, we've said, when you have shown discerning use of mathematics in this task, we think this looks like you've done these things. Yeah. Yeah, so we've kind of done that, and then we've pulled that scaffolding away as the years have gone. There was the ones that we've just come into year 11, we just gave them the ISMG. But I was going to say, in year 9, I don't know if any of you use Cambridge in year 9, but in Cambridge in year 9 in the Pythagoras chapter, there's a question that says, which is a better fit, a square peg in a round hole or a round peg in a square hole? Yeah, I did that one as a PSMT in class, yeah. And I just said, what do we have to assume? What does better fit mean? What are our variables? Oh, we've got the radius and the side of the square. Now, the problem for us, I think, with that is that it's the same question for all the kids. Yeah. And we need something that's a bit more individualized in terms of like jumping through the hoops later on. Yeah. And for me, that's a lot of the problem with the very guided PSMTs, is that it's really a joy to mark because everybody gets the same answer, but that authentication becomes really hard. And so we tried to find things that you could like find data sets for. Although joyously the Australian government stopped funding the census at schools, the New Zealand government, yay, they haven't stopped funding it. And you can still access the New Zealand census at school, and they've still got data from Australia. And yeah, if I could vote for a party that was just going to reinstate census at schools, probably would go, yeah, you're fine, you've got my vote. Not that my vote makes any difference, but so that was a really good one. I'll come back on to PSMT, so I'm just going to mention the other ones. We use OneNote. I don't know who else uses OneNote. So the kids have write-on tablets. We use OneNote. I make the OneNotes. We have mentioned Cambridge lots of times that we do this because it's an independent school. We can kind of check their book lists and force them all to pay for it and everything. So I appreciate that's more complicated. But what it means is when I do a OneNote section, I clip in the syllabus dot points at the top of each OneNote section, and I clip in the bit of the formula sheet as well, so that when we have each section, that everybody is focused on what the syllabus dot points are as well. We do a revision test every fortnight. Some of those come from Cambridge, some of those we write, but we're just like massively interspaced practice as a way to prepare kids for exams. And also just to, I think it's because we teach boys, sorry to all the men in the room, but we just think they have a tendency to kind of go, she'll be right. You know, do you know all of this? And they're like, yes, I know all of that. And you go, well, really? Do you? Show me that you know that. And they think that they do and they don't. So yeah, that's just, I don't know if that helps go.
When you say a fortnight, is that in class?
So no, we give it to them. So actually that's an interesting thing. So what we do is we write it, we hand it out to them. They have to bring it back into class, and the bit they do in class is marking it. So which may be, again, a reflection of our obsession with the mark scheme. But what we wanted them to think about is exactly everything that Michael was talking about before. What is actually valued by an examiner? Like, because they'll do things like write down, you know, what is the y-intercept? 3. And we're like, well, was that what the examiner wanted? Was that what the question asked? What is being valued? And so we try to write mark schemes that say, like, what's the bit of maths that we want you to do? And that's very much following from what the QCAA mark schemes look like. So if they say things like, so hearing everything that Michael's saying about the ones that they're developing is really, really good, because we're trying to get the kids to interrogate their own work. So they work in pairs and kind of mark each other's to interrogate it. Yeah, and then I collect them in at the end and stare at them in a slightly sad way for a bit, and then go and find the child who knows nothing and say, you don't know anything. That's not really getting much further than that sometimes, but that's it. All good, yeah. Yeah, so this is it. So I guess the second part of that, do the kids understand the ISMG, is we as a group of teachers wanted to make sure that we have a shared understanding of what the ISMG means. I think that you as a department have to have a shared and common understanding, and I also think that that shared and common understanding probably has to go from at least year 9 through, because if you've got some kid who's been told really, really firmly in year 9 that this is what reasonableness is, and then suddenly in year 12 you go, ha, but that's not what we mean by reasonableness, that, you know, you're just going to stuff them up. So I think that we feel that we've got to somehow reach consensus across all of us, and that's proving quite hard. The other thing I was going to say just about the textbook is I hadn't particularly been following these Enrich. I do it a lot in year 9 and 10, like I hit up Enrich all the time. But I found this one, this tangled trig graphs, and I've just finished teaching trig to 11 methods, and I thought, I really like that task. I like tell me about all the other ones. So I always quite like, the links to Enrich, I really like them. I quite like them as problems to just go away and have a think about, and about, it's, for me, a lot of it's in that formulate and evaluate. Like, I think kids are generally okay to solve. What they don't get is what we mean by formulate and evaluate, yeah? Like, how do, and I'm completely being sexist here, because I just think it's boys, because I've only taught boys in Australia, that they just kind of go, she'll be right. Like, how do you know you're right? Well, because I have used correct mathematics. The amount of time I've read that in evaluation, the mathematics used was correct. I'm like, no, that's not an evaluation. The reason I started doing stuff, because I started doing stuff for the QAMT on PSMTs, was literally because I wanted to know what other people were doing, not because I think we've got the right answers. Actually, back to the PSMT, I'm sure a lot of you know Peter Fass. I'm really fortunate to get to work with Peter Fass at Grammar these days. But he made the really good point that we absolutely have to have a common understanding of what the ISMG means, because if we in any sense double dip kids, like we knock them a mark for doing the same thing wrong, and we say, oh, that's a solve problem and an evaluate problem, then when we have those kids who are really chasing that ATR 99.95, then we are taking 2% off every, and in this situation where they can get 97% and still get 15 on IA2, yeah, or whatever, it's not 15, is it? But you know what I mean, like, it's a significant thing, and we have to have a really clear understanding of what we all mean by that and what our standards are, because it's just this, that's why we got, I guess, so obsessed with it.